Hi, this is King of Review. Find an equation for the nth term of the sequence square root 3, 3, 3, square root 3, 9, and the sequence continues. So the first step here is to determine if we're working with a geometric sequence. A geometric sequence is a list of numbers or terms where the ratio of any term to the previous term is constant. So each of these numbers here is a different term. This first number is the first term and we call it A1. The second term is called A2, and this naming pattern continues. The third term is called A3. The fourth term is called A4. So what we want to do is figure out if there is indeed a common ratio in this sequence of numbers. So one method for determining the common ratio is using the equation R equals some term compared with its previous term. So let's compare A3 and A2. So you can see I'm comparing the term A3 with its previous term, which is A2. So A3 is 3 square root 3, and A2 is 3. These 3's cancel out, and we're left with square root 3. So far, it looks like the common ratio is 3, is the square root of 3. So now let's compare another couple of terms. If we have R equals A2 over its previous term, which is A1, A2 is 3, and A1 is square root 3. So we have 3 divided by square root 3. To get rid of the square root in the denominator position, we'll multiply the top and the bottom by square root 3. And now we have 3 square root 3 over 3. These 3's cancel out, and we're left with square root 3. So you can see we're getting the same common ratio as we see here. So what does this mean? This means that in order to get from the first term to the second term, we must multiply by the square root of 3. And to get from the second term to the third term, we're going to multiply by the square root of 3. And this pattern continues. To get to the next term, you must multiply the previous term by the square root of 3. So now we've determined what the common ratio is. The question asks to find an equation for the nth term. The rule for a geometric sequence is an equals a1 times r to the n minus 1 power. The nth term of a geometric sequence with a1 as its first term and r as the common ratio. So let's enter in some information into this equation and see if we could come up with an equation for the nth term. So we have an equals a1, which is the first term, that's square root 3. So square root 3 times the common ratio. We've determined what that is. That's square root 3 to the n minus 1 power. Now, you see that we have two square root 3 numbers here. So square root 3, this first square root 3, can be written as square root 3 to the first power. This is the same thing as square root 3. And we have times square root 3 to the n minus 1 power. You see that we're multiplying two numbers that have the same base. Remember the rule that if you're multiplying two numbers that have the same base, so x to the a power times x to the b power, this is going to equal x to the a plus b power. So when you have bases that are equal, then you can add their exponents. So let's apply that to our problem here. An equals square root 3, because square root 3 is the same base and we're multiplying these numbers together. So now we can add the exponents. 1 plus n minus 1. And now let's simplify. An equals square root 3 to the n power. So now we've come up with this rule that represents this geometric sequence. So letter A is correct. And a good thing to do after you've come up with the equation for a geometric sequence is to test it and see if it's true. So let's test it with A2. So we know that A2 should equal 3. So let's insert that information into the equation and see if we get 3 for the answer. So we have A2 equals the square root of 3 to the second power, and we want to know if this will equal 3 or not. So the square root of 3 is the same thing as the square root of 3 times the square root of 3, and this equals 3. So yes, this equation is correct. Thanks for watching.